Hi, this is the third and last video regarding the Niagara Falls SQL integration that I want to show you. In this demo, I want to cover one last thing I hadn't covered before, which is bringing points in from a SQL database by creating a SQL query in Tridium. And then I want to pivot over to how to use your data in your SQL database that you brought from Tridium to create new tables and create new data. Um, so here we go. So the last thing I wanted to show here, well, under points, you can create queries that directly query the SQL database. In my SQL database, I went ahead and create a table that goes through all the different points. It goes through all the records in every single point collection that we exported from Tridium to SQL, and it looks for points that have the flag of fault. So any points that were at fault when Tridium collected that trend log, we're going to grab them and put them all in this one big table called fault data samples. And then we're going to order by timestamp. So hit OK. Once we do that, we should be able to access it and then discover. And there we have all points in this station that have been logged while being in fault or at fault. We should have a log here of the point name, the timestamp when the fault happened or when the log was recorded and the point was at fault, the value that we had, and so on. But really, this is not super helpful here in Tridium. Not as helpful, I think, as it could be in something like Excel, Access, or Power BI. Or at least maybe I'm just not sure. I don't know how to use this data the way I want to use it in Tridium as I would in any of these other platforms. So that's where I'm going to leave Tridium here for today. And I'm going to focus a little more on playing with the data that we brought from Tridium into SQL. So as you can see, this is Visual Studio Code, which is an environment that I like to use for developing. Um, this is the SQL Server extension. I created a SQL connection to my database. This is the Tridium database that we've been working with, and these are all the tables. There's one table, however, that we never actually brought from Tridium. We actually, like we just discussed, created here in SQL. So let's view that one. So this is the SQL project where we have all our SQL query files, and now we just created a trigger that we're going to add schedule task manager so that it runs once a day and it recreates this table and it gives us all the latest points that have been logged at fault. So let's take a look at this query here. So we run that query, and here we see essentially the same data we were seeing in Tridium, but in a nice table format. So, but how did we create this table? Now I guess that's what we need to answer. So here I created some SQL scripting. The first thing that we do is we let SQL know that we want to work with the Niagara database. If the table, because the table typically already exists, once we've developed the SQL query, we run it right away, it creates a table, and then we can add this statement so that anytime our PowerShell script runs and recreates this table, first we drop it and then we recreate it. So here in this statement, we're creating a new table called fall data samples. These are each different column in the table. That's how we define the columns. And here we're going to declare a couple of variables, table name variable and the SQL string variable. Um, Here we're going to declare another variable, which is a temporary table. And here we are going to declare a cursor. And so what a cursor does is it's going to um, loop or iterate over X number of values. In this case, it's going to iterate over the values that are the result of this query, this SQL query, which is querying all the tables in the information schema object that have a table type of base table, a table catalog of the database we're looking for, and are not named the database that we created, which ultimately will hold all these records. And then we're going to order by table name. So in this instance, we open the cursor and we run it, and every time that this query outputs a result and we curse through it, we're going to run this um, string which we're adding to the variable, and it's basically the string that's going to insert the data. Um, so it is a little bit convoluted, but and the reason it's convoluted is because this is not standard for relational databases. Um, as you see, we're not doing any joins here or anything like that. So, and the reason for that is because of the way the database is structured. Just tons of tables with very simple schema, like 4 or 5 columns. And this is just the way that the schema came from Tridium. Um, so, in any case, once we're done iterating through all the tables, we just close the cursor, and that gives us this new table. So every time we run this script from now on, it'll drop the existing table and recreate it with all brand new values. So of course this is going to be based on all the different times that we continue to log values that have a false status in all these other tables, which we continue to pull because there's that integration between M4 and SQL. Right? So lastly, we need something to trigger that SQL script once a day, and so that's what this script here does. Here's the base directory for our project. Here's the name of the file, the SQL file that we want to run, and a timestamp so that we can send a log file to this retry logs folder. And then it's as simple as that: invoke SQL command and then output to the log file, whatever the output is. So, and then I'm not going to show because I think it's pretty easy, but what you'd want to do with this PowerShell is create a task in schedule manager. Let's see, in task scheduler. So you'd go to task scheduler and then you'd add this, reference the path of this script. Script has no arguments, and then you set it to run once a day at a certain time of day, like 2 o'clock in the morning or something. And that's basically it. So if we run this script, we should see it do something. So some of these tables are going to fail because they're not data point tables. So, like for example, I would expect this audit history to fail. So all of these ones that you see here with invalid status column is because they didn't have this column or this value column, because that's what we were looking for on any of the points. So, but we can disregard this error because this error just only applies to things like the audit log and the security log, which are tables that we brought from Tridium, but they don't have the same schema or the same columns that you'd find in a point trend log. So, and that's pretty much all I have. Um, if I run this now again, I'm gonna have the same amount of data, but as you can see, we have data. So the last time I had a point that was faulted was it was the binary pulse out of my ECY on the top rack and value of 0, and this was the timestamp. So lastly, so what do we do with this data now? Because Visual Studio Code is great, but ultimately um, we want to be able to use this data somewhere where different audiences it can reach different audiences, right? So I connected the SQL database to Power BI. So here's an example of a Power BI report, and here you can see the same table that we saw. It's rolled up by day, whereas the original source data has 15-minute interval data. Here we're only getting one record for the day. Um, oh no, hang on. Here's a few records per day. But anyway, I'm not sure how the roll up here worked because I do see that I have less records than the original source data table. But that's or need to figure out Power BI a little better. In any case, here's some slicers. So the interesting thing is that I love how with this slicer I can just ask for a specific time frame, and I can say, hey, from this time to this time, show me all the points that were faulted, or show me only the power supply point or the power supply and or just binary value 106. Um, so really, I think the only one that repeats here is power supply time. So, and that is pretty much all I have for today. So, hopefully you enjoyed the content. See you next time.